industry on parade. A pictorial review of events in business and industry, produced each week by the National Association of Manufacturers.
This is the granite center of the world, Barre, Vermont, where workmen the year round carve out of the earth one of nature's most beautiful non-precious stones. The fluted terraces in a modern quarry like this show the care that's taken to remove the granite. The first step is a process called channeling, which frees huge stone blocks from the bed of the quarry. A drill bores holes into the top and sides of the granite in a precise pattern. And to keep the dust from harming workers, vacuum tubes are laid beside the business end of the drill, sucking in the dust particles. Because of the delicate structure of granite, it is seldom blasted in quarrying. A block usually can be broken loose by driving wedges into the series of holes that are drilled into the top and sides. But when blasting is necessary, the quarry workers at Barre know exactly how to do it without injury to the stone. After a block of granite is jarred loose by the blast, a heavy crane lifts the stone to another section of the quarry where it's given a preliminary trimming with sledgehammers. The workmen also examine the block to make sure there are no cracks. Then it's loaded aboard flat cars that freight it to the finishing plant. The huge block is machine cut into smaller sections by gang saws, which have from 2 to 10 steel blades. Giant electric wheels do the polishing in 4 stages, ranging from a rough polish in which steel shot is used to the smooth polish, which requires only putty and a felt disc. It's a rarity when a slab of polished granite reaches the inspection stage with a flaw in the grain. But when it does happen, the flaw must be chalked off and cut out. In years gone by, all this work was done by hand. A hammer and chisel, the only implements used to cut into the solid rock that withstood the ravages of millions of years, buried in the mountains under ice and boulders. Today, modern abrasives and air-powered tools do the job, turning the rough granite blocks into beautiful works of art dedicated to mankind.
History shows that we Americans have attained the highest standard of living in the world. The competitive American system, based on freedom for the individual, has encouraged us to develop new and better raw materials and to improve our buildings, equipment, and tools. As a result, we now produce 3 to 4 times more per hour than we did in 1850, while we enjoy nearly twice as much leisure. We can have an even higher standard of living in the future by increasing our productivity, which will mean more and better products for all.
Notice anything remarkable about this home in Muncie, Indiana? No chimney. The answer to the riddle may be found at the Muncie Gear Works, where they manufacture a device called the Marvair heat pump, which heats a building in winter and cools it in summer by utilizing the constant temperature of the earth. The heat pump we see being assembled here will keep the interior of a home at a steady 75 degrees, or whatever temperature is most comfortable, day and night, summer and winter, without using a penny's worth of oil, gas, wood, or coal. Actually, the Marvair achieves this apparent miracle with the same principle applied in an electric refrigerator. And it is basically a big refrigerator, without storage space and with some important additional equipment. Like a refrigerator, it has tubes filled with a unique substance called Freon. Freon changes from a liquid to a gas very readily, and in doing so gives off heat. Then it readily absorbs more heat, which it again gives off when it's compressed back into a liquid. What Marvair does is let the Freon pour off that heat into the home. And where does the heat come from? It comes from water circulating below ground, where the temperature remains the same all year long, warmer than the atmosphere in winter, cooler in summer. Let's follow this unit along and see how it operates in a home. The installation men have been preceded by well diggers in most cases, who have sunk a shaft through which water can be piped to bring heat out of the ground during the cold months and put it into the ground during the warm season, when the system is reversed to keep the house cool. The water is pumped out of the ground, its heat is absorbed by the Freon, which is then compressed and passed into a radiator, giving off the heat again to be forced by blowers into every room in the house. Comfortable living without soot, without furnace tending, without seasonal variation. The ladies enjoy their afternoon with air conditioned by Mother Nature herself.
In this 3-acre plant of the Cooper Alloy Foundry Company in Hillside, New Jersey, big things have been going on, of which the general public is, for the most part, unaware. Tom McLear, chief foundry engineer on the right, was one of the leading lights behind the important new developments. Cooper Alloy Foundry is the world's leading producer of stainless steel valves, fittings, and castings, all requiring individual molds made chiefly of sand. Here's how Tom McLear worked out a way of preparing molds that use about 1/10 as much sand as the older method. In his laboratory, Tom heats the pattern for a mold to 500 degrees, then coats it like this with just a thin shell of sand mixed with resins. Back into the oven goes the coated pattern. Within a few minutes, the coating has been cured into a rigid shell, bearing in reverse every minute contour of the pattern. No ordinary mold could be carried around like this by one man. The pattern and mold are separated, and now we see that it's a mold for a number of valve parts. But there are 3 parts to a mold: the top, the bottom, and the core. Harry Cooper, the firm's president, followed McLear's experiments carefully during the 9 months he was researching this new method, and here Mr. Cooper puts in the cores himself. The molten metal will flow into the open spaces between the cores and the upper and lower shells. Did these men go to all this trouble and expense just to save a few pounds of sand? Not at all. Here on the production floor, we can see some of the tremendous advantages of the shell mold process. An amazing machine has been developed which produces a shell mold in just 2.5 minutes. A moving oven comes forward to raise the pattern to the proper temperature. Then back it goes, and a dump box charged with the sand and resin mix moves into position. Over she goes to coat the pattern. Now, heat must be applied again to harden the mold. That, too, is accomplished without delay by the moving oven. As soon as the oven is out of the way, another part of the machine comes into play, to separate mold from pattern. And there we have a mold completed in about 1/5 the time it would take with the old methods. The upper and lower shells are held together, very simply, by strips of adhesive. Because of the tremendous quantities of sand usually used, foundries are often a lot messier than management or employees would like. The shell mold system promises to end all that and create much more pleasant working conditions. But equally important, it saves on critical metals, particularly nickel and chromium. Also, only about 1/3 as much floor space is required as for conventional mold making. And what does all this mean to the average citizen who wouldn't recognize a casting produced here if he saw one? It means much greater production for both the military and civilian economies, and at lower cost. For whether we know it or not, we all depend in many ways on the products turned out in plants like this. And any such drastic improvement in the methods of turning them out benefits every one of us. That's all there is to it. As soon as the metal has cooled into a solid state, the shell and core are shattered free and the castings are ready to be cleaned, cut apart, and finished. These castings are much closer to the specified dimensions than they would ever be if produced conventionally, so there'll be much less machining necessary to bring them to the exact size and shape required. Another behind-the-scenes research project that pays off for everybody.
The communists would like to see inflation cheapen our money until it isn't worth the paper it's printed on. Cheap money means less value for our savings and insurance. That's why the communists would like to see cheap money create economic chaos. But we can curb inflation and strengthen our dollars if each of us will avoid borrowing to buy unnecessary things, by saving all we can, not wasting materials, and by supporting policies which increase our industrial productivity, and by insisting our government does likewise. A sound dollar means a strong and free America.
Liner United States, pride of America's merchant marine. The fastest passenger ship afloat, it's also a marvel of efficiency. And that extends to every department, including the stewards, who for 6 weeks before the ship's maiden voyage went through a thorough refresher course on all phases of their jobs. Here at the U.S. Maritime Service Training Station at Sheepshead Bay, Brooklyn, more than 500 men learned, first of all, the geography of the huge vessel and its miles of passageways and compartments. Making beds is old stuff to these bedroom stewards, but the refresher course will prove that they are experienced in the proper ways of keeping staterooms shipshape. The U.S. Lines is determined to maintain the highest level of service on its new ocean beauty. In a mock galley, 178 chefs and their assistants demonstrate that they know all the ins and outs of such arts as pie baking. There's high specialization in a galley like this. A pastry cook would not make sauces, and a soup chef would never attempt to carve a piece of meat. Row chefs perform that task with speed and skill. For waiters, the correct setting of places is only a beginning. Experts like these pride themselves on giving constant attention to the needs of the diner, while remaining as inconspicuous as possible. That applies also to service in the staterooms. Every last member of the crew must know how to handle an oar, and the men who might be a little rusty get plenty of opportunity to brush up on their skill during the 6-week course. The men of America's merchant marine, like the ships they sail, remain the finest of any nation on earth.
Was developed by scientists of the General Tire and Rubber Company after long research, financed entirely by the firm without government assistance. Through long months, the research engineers attacked one of the basic faults of ordinary synthetic rubber, the fact that it's so tough it's difficult to fabricate into tires and other products. It can be fabricated, but the operation is long, and rubber loses some of its strength in the process. So revolutionary new techniques were tried, such as more thoroughly mixing the ingredients by dispersing them in water. Also, new means were developed of incorporating rubber softeners that would not deprive the finished product of its toughness. But the most remarkable outcome of the project was the development of a method of producing synthetic rubber that gave 22% more of the finished product than could be obtained by the old-fashioned methods from the same amount of raw materials. Blending with a coagulating solution of salt and acid, the material immediately becomes a homogeneous mass of tough, plasticized rubber. The electric stir assures that the entire mixture is exposed to the coagulating agent. When the stir is turned off, black synthetic crumb rubber rises to the surface. Produced in this fashion, but of course in much larger quantities, the new product is already helping to meet our critical rubber shortage. First step in putting it to use is to press the crumbs into bales. As needed, the bales are brought out of storage for shipment to the factories where they'll be fabricated. This particular batch will end up as tires, so let's follow along and see how a tire is put together. First, it goes into the Banbury where it's mixed with certain chemicals that will give the rubber characteristics required for the job it will be called on to perform. From there, right into the warm-up mill where it's softened so that it can be formed into the shape of a tire tread. From the warm-up mill, the strip is forced through a die and is extruded roughly in the shape of the tire tread. It doesn't look much like a tire tread at this point, but that's because there's further shaping ahead. The machines do most of the work, but a human eye and mind must keep constant tabs on them. The endless strip of tread is cut to the precise lengths needed for each tire size. It's all automatic and extremely accurate. A tire builder starts construction of what's known as a tire carcass. The finished carcass is ready to assume its final shape in a vulcanizing press, a piece of equipment that represents the latest mechanical development in the tire-making field. The press comes down and high temperature and pressure do the job. Equipment like this could turn out all the tires required by the entire world, but the government synthetic rubber plants have been unable to keep them fully occupied. Now, industrial research has come up with a way of increasing synthetic output 40%. For civilian as well as military tire users, the new methods mean 8 tires in place of the 5 produced by conventional methods. And how do the new tires hold up? In severe tests in the labs and on the road, they amazed old-time tire men by outperforming tires made of the softer synthetic. That's how to put a smile on the face of a good research man.
We Americans are always trying to find better ways of doing things. Our forefathers who pioneered and discovered new frontiers in this country have been supplanted by the scientists and technicians in American industry's laboratories. Every day, every week, every year, someone is discovering a new product or improving an old one which will benefit all of us. Each year, industry spends $750 million in research that creates new jobs, more and better products, which help all of us to continually improve our standard of living.
Industry on Parade journeys to Linden, New Jersey, along with 1,900 other citizens, for a close-up of an old tradition in the American industrial scene. It's an annual stockholders meeting like that staged by all corporations, at which the actual owners, men and women from all walks of life who hold stock in the firm, gather to exercise their authority over the officials they have elected to direct the organization's day-to-day affairs. The scene of this stockholders meeting is nothing fancy, the boiler shop of an affiliate of Standard Oil Company, New Jersey. But these 1,900 of the company's 222,000 stockholders are here for facts, not fixins, and they get them from Jersey Standard Board Chairman Abrams and President Holman. Questions or criticisms are relayed to the rostrum through a portable microphone tied in with the public address system. It doesn't matter whether you own 1 share or 100. Everybody has his full say under democratic rules of procedure. Women own a good share of American companies, and they're taking an increasing interest in seeing that those companies are run in the best interests of everyone, stockholder, employee, and public alike. The man who usually gives orders has to take them on this occasion, but actually the meeting is remarkably harmonious, with no real difference of opinion between stockholders and management being manifested. One interested group of spectators are plant employees who grab a few minutes from the job to learn how the chain of command in our society leads right back to the people themselves. Finally, reports made and votes taken, the meeting breaks up for lunch. And this, too, is in the American tradition with an old-fashioned box lunch for all hands. A unique backstage look at one important phase of the American system of free enterprise.
Industry on Parade drops in on the Steel Craft Manufacturing Company of Ross Moines, Ohio, to watch a medium-sized firm that's doing a bang-up job of turning out military orders while at the same time maintaining full civilian production. Steelcraft produces a wide variety of steel building products and specialties. It developed its market for these goods starting from scratch when it reconverted to peacetime production after World War II. Now the military orders are pouring in again, and it calls for real know-how to keep old customers happy while doing an all-out job for Uncle Sam. Experience at making such things as window and door frames put the company right in line to become a prime contractor in the manufacture of parts for Bailey bridges for the Army. The Bailey Bridge is a versatile, collapsible steel bridge that can quickly be thrown across a stream or culvert. Hundreds of them are in use in Korea, and many more are needed. Though the panels for the prefabricated structures measure 10 feet by 5, they must have a tolerance of less than 1/32 of an inch. That calls for real engineering. To demonstrate for Steelcraft employees and other residents of the Cincinnati area one of the many phases of defense work being performed here, the 478th Engineer Combat Battalion prepares to assemble one of the bridges on the campus of the University of Cincinnati. Before assembly, even as it goes up, the Bailey Bridge looks a great deal like a child's erector set. And in fact, it's based on just about the same principle. In parts of Europe, bridges like this one still span rivers, replacing bombed-out structures that have never been rebuilt. The bridge comes complete with timbers for the flooring, all knocked down for easy transportation until it's ready for use. Last to go on is the footpath for the doughfoots that goes on the side of the bridge. And there it is, fully assembled in less than an hour and ready to keep the tanks, trucks, and foot soldiers rolling forward.
Every American feels the effect of inflation when he goes to spend his money. Inflation, created by more money than goods to buy, has robbed our dollars of half their value. The government feels it when it goes to buy defense material. Our savings, insurance policies, and pensions have all been reduced to about half their former value. No one escapes inflation. It taxes the housewife when she does her weekly shopping. It robs the farmer when he buys tools and machinery. It strikes at the manufacturer who produces those farm implements. The only way to avoid inflation is to prevent it by sound taxation and wise government spending.
Men working in trees, the sign says, and the men in those trees are the real-life Tarzans of the Asplin Tree Expert Company of Jenkintown, Pennsylvania. Their job? The highly important one of preventing trees, vines, or underbrush from endangering our indispensable power and communications network. On assignment from public utilities all over the country, the tree experts keep the right-of-ways cleared, minimizing the possibility of blackouts as a result of high winds. No one minimizes the importance to the nation of our electric and telephone services, and those services are most important during storms. That's just when they'd most likely be knocked out were it not for the work of these men. By cutting down dead trees or those rotted away, the tree experts help beautify the areas in which they work, as well as reducing hazards to life and limb. Their powerful spray guns also help the trees to withstand the ravages of insects. It's the sort of service you won't find in the best-tended big city park. Trees cut down are not left behind to become eyesores, but are sawed into small sections and hauled away. Even small branches are ground up and trucked away, for it's a standing policy of the tree experts: when you leave an area, leave it looking better than it did when you arrived. Industry on Parade. A pictorial review of events in business and industry, produced each week by the National Association of Manufacturers.
Hundreds of tons of corn cobs arrive at the Omaha plant of the Quaker Oats Company. Like rice, oat, and cottonseed hulls, corn cobs are a byproduct of agriculture that generally are burned just to be rid of them. But these corn cobs will not be burned. Instead, they'll have extracted from them the important chemical furfural, basic to the manufacture of nylon, synthetic rubber, plastics, petroleum products, and other goods. From collection stations, the corn cobs are shipped to Omaha by boxcar and truck, and there are transferred to storage elevators by means of some truly amazing equipment for handling materials. It takes an awful lot of corn cobs to produce a pint of furfural, and it's only by employing techniques like these that the plant can produce the chemical economically. And how such techniques have brought down the price from $1.50 an ounce formerly paid for furfural imported from Germany to less than 1 cent an ounce when produced at American plants like this. From the elevators, the corn cobs go to rotary screens for the removal of foreign matter. From here, they move directly to grinders to be reduced to about popcorn size. Now they're given another ride upward into the silo from which the material will discharge into tanks called digesters, where the chemical processing will begin. In its passage from silo to digester, the material is automatically weighed while moving along at great speed. Thus, precisely the required amount is deposited in the bottom of the digester. And after catalysts have been added to speed up the chemical reaction, heat and pressure are applied while the digester rotates. Like any chemical plant, this one is remarkably quiet and orderly, with very little going on in view of the eye. Only the dials reveal dramatic details of the progress being made inside the digesters. Skilled workers keep a vigilant watch over those dials and coax furfural out of the corn cobs and into steam vapors, which are then distilled to produce the pure chemical we seek. Out of the bottom of the digester pours the residue to be conveyed to a power plant and used as fuel to make steam that will produce still more furfural. A classic demonstration of the way in which modern industry seeks to utilize every particle of energy from the raw materials God has given us, putting to use even those that for centuries were regarded as sheer waste products, and helping to develop from them brand new substances with brand new applications. Not mere substitutes for older materials, but products with entirely different properties.
America's new frontiers are in science. Today's pioneers are found in the research laboratories of industry. Engineers and scientists are constantly searching for new discoveries which will benefit mankind and help raise living standards. Today, there are 120,000 scientists in the nation's 2,300 industrial research laboratories, and more people trained in science are needed. It's estimated that 40,000 engineers are going to be needed every year just to meet our minimum requirements. So when choosing a career, consider the field of science.
A young Chicago family drives down to Park Forest, Illinois, for a look at a community that's as orderly and well-planned as their own big city is sprawling and confused. 27 miles southwest of the Loop, Park Forest is an experiment in city planning that's already proved successful. A community of rented and privately owned homes that's far more than just another housing project. 5 years ago, it was 2,400 acres of cornfield and abandoned golf course. Now it's a town of about 20,000 residents, with all the conveniences of a city and none of its discomforts. Our young Chicagoans have just about sold themselves on the idea of living 10 families to the acre. Also on the idea of moving into a town that has the look, feel, and sound of youth. Built by private enterprise, this unique development was based neither on the idea of giving people something for nothing, nor on the hope of making a fast dollar and pulling out. Rather, its founders sought to build a sound community that over the years would pay back their investment through income from the shops and stores whose goods and services a sound community requires. You might say the backers of Park Forest invested in the integrity of youthful Americans like our veteran friend and his family. Judging from the new construction apparent at every hand, the faith of those builders was very well founded indeed.
Driving in a closed car on a stifling hot Texas day? That's right, and in heavy cowboy regalia at that. The reason is, of course, the car is air-conditioned, with equipment made here at the Frigicar plant in Dallas. The Frigicar is basically like home or office air conditioners, except that it must be more compact and rugged enough to take the vibrations of an automobile. Although auto air conditioning has been around for 12 years, it's only now beginning to catch on. At auto sales rooms in the warmer climates, mechanics are getting more and more experience at installing the equipment. The cooling unit fits out of the way in the trunk compartment. Refrigerated air is forced through flexible tubes to clear plastic ducts on the package tray behind the back seat. These ducts keep the rear window from misting over and also keep drafts off the necks of passengers. The compressor is mounted under the hood where it's driven by a belt connected to the crankshaft. So the only electricity needed is that used by two small blowers. The condenser unit also fits under the hood, between radiator and grill. So rapidly has this auto air conditioning idea caught on that for 1953, Detroit is making air conditioning optional on several makes of new cars. King Eden Saud's fleet of limousines have been air conditioned for some time. But now, with the units in mass production, the rest of us are going to have a crack at this new comfort on the road.
A shopper on her way home, carrying her purchases in a variety of bags made of paper, perhaps, or cloth, closed or open mesh, and all produced so efficiently that storekeepers can afford to give them away free. Chances are they came from the Bemis Bag Company, whose St. Louis plant is visited by our cameraman for a report on one of the more popular types of bags turned out here, Visinet. Rolls of quarter-inch craft paper ribbon are set up on spinning machines to be spun into yarn in just about the same way that cloth yarn is spun. The ribbons are threaded through eyes that will fold them, then over rollers that apply tension, and finally onto the winding spools, whose rapid turning twists the folded paper and gives it still further strength. In developing this unique use for paper, Bemis was forced to perfect techniques and machines never used before. But for the most part, the methods of the cloth fabric manufacturers have been adopted. As, for example, in weaving the yarn into Visinet, a net through which you can see and thus inspect the oranges, onions, or potatoes inside. On another machine, the Visinet is automatically cut and folded, emerging ready to be sewed together as bags which will have printed on them the name of the company that will put them to use. In addition to making their contents visible, bags of Visinet also have the advantage of providing ventilation for vegetables and fruits. Skilled operators sew the bags across the bottom and up the side in an endless chain that will be snipped apart later. This is only one of a number of sizes in which bags are made from this remarkable paper netting. They're cut apart as they're stacked. And here's Madam Shopper arriving in her kitchen with the groceries. She takes the bags in which her food is packed completely for granted, quite unaware that in most countries, shoppers must provide their own bags or other containers for food purchases. Were it not for firms like Bemis, it might be the same story here.
Since 1939, inflation has been chipping away at our 100-cent dollar until today it is worth only 52 cents in the grocery store or the savings bank. Unless we check further inflation, there is no telling how much the value of our dollar will slip. Certainly none of us wants a 25-cent or 10-cent dollar. The way to curb additional inflation and start building a sound, healthy dollar is for all of us to increase production. We must insist that our government practice strict economy, cut out all waste and extravagance, and balance the federal budget by a realistic tax policy.
Here's a Haddonfield, New Jersey salesman bidding goodbye to his family as he sets out on a business trip to Massachusetts. Did I hear someone ask, Massachusetts? Well, that's just where Harold Pratt is headed. And what's more, he'll be back in New Jersey with his family by nightfall. No, he won't make the trip entirely by this method. The scooter is only part of a transportation parlay that allows Harold to represent the Philadelphia firm of David Michael and Company throughout all of New England. The other part is a single-engine Cessna 170. Arriving at the airport, he folds up the scooter and packs it in a bag before stowing it away aboard the plane. At the other end, he'll unpack it and zip off to call on his customers, ice cream manufacturers to whom he sells vanilla powder. A pilot in World War II, Pratt struck on this system of covering a wide region after contemplating the alternatives. Long sessions at the wheel of a car, eating and sleeping in hotels, and seeing his family maybe once a week. This way, he can cover twice as much ground and still get home every night. So away goes Harold on his appointed rounds. And along about dinner time, back he comes with his order book comfortably bulging. Here's one fellow who stopped talking about the advantages of the air age and gone ahead and put them to use. But while we're passing out compliments to Mr. Pratt's airplane, let's not overlook the other half of his travel equipment. The other half of this airplane-scooter combination that's become Harold Pratt's daily double, one that pays off every day.